All right, so we are in Algebra 1, Lesson 8-7. Today's date is Friday, February 14th. Happy Valentine's Day.
You too.
Thank you. Who wants to read our objective? I did not pass out cards, but we'll just go fast today. I think I saw Jade's first.
Write functions from the real world about exponential decay.
There it is. All right, so as a review, exponential growth looks like this guy. You have your final amount is equal to your start, which we are also calling our initial amount. Then I multiply by this factor. The way that I find this factor, I do 1 plus whatever the percent is, or if it just tells me the factor, I'll write this note here, factor. This whole thing right here is the factor. If it gives you a percent, then this is the way that you find the factor. You add that percent to 1. But if it gave you the factor, it's even easier. You just say that's the factor. Does this ring any bells? This is from about a week ago, lesson 8-2. So an example equation might be something that looks like this. You could have, I don't know, I'm feeling like a g. G of x is equal to, I don't know, someone shout out a number.
5.
I heard 5 loudest. 5 times, and then I'll do 1.37, all of that to the power of x. Done. That's what it looks like. So this is saying, hey, my start amount is 5. My initial amount is 5. I am increasing by 37% because 0.37 added to 1, and 0.37 is a percentage of 37%, moving the decimal place twice to the right, which means if I want to convert the other way around, I have to move twice to the left. So if it gives you a percent, move it twice to the left. That's going to be happening over and over again today. And then to the power of x. All right, so what do you think exponential decay? So we have exponential growth. How do you think exponential decay is going to look like? It's almost the same thing, a little bit different. Wyatt?
Would it be the start amount or the initial amount divided by 1 plus the percent to the t power?
You're really, really close. 1 plus your blank percent to the power of t. You're really, really close, but this is still going to be a multiply sign, which means you're going to have to do some other operation. So if I change this to a multiply, this is almost correct. Anyone else want to take a shot? You can go it again, Wyatt. It has to do with our factor here. Yesterday we learned that if the factor is less than 1, then we have decay. Esha?
Would we do 1 minus because it's decaying?
It is indeed 1 minus. The only difference is the plus turns into a minus, and then we have the same exact formula. And I'll make the note out here on the right-hand side. When the factor is greater than 1, that's growth. And when the factor is less than 1 and greater than 0, still a positive number, that's going to be decay. So that's the main reason that we have a plus and a minus. All right. Let's try using out this new equation down here that we've written with a minus sign. For example number 1, Charles is not here to read this, but there he is. Who wants to read Charles's new computer question? Anyone that still has their imaginary card? Those people, yeah, Eamon.
Charles buys a new computer for $1,200. The average
Depreciation.
of computers is 45% each year. Write a function that gives the computer's value v parenthesis t years after Charles buys it.
Perfect, there it is. And I actually looked this up online. The depreciation of computers is actually 50%, but I made it 45% to make it a slightly harder problem. Yeah, so what are we going to do? We need a start amount, we need a factor, then we're done. Who wants to find one of them? Yeah, Kira.
Well, the start amount is 1,200.
1200. And I want to make a note here. Yes, it is 1,200, but if you in Khan Academy put a comma here, it's not going to consider it correct, so don't do commas. Did you want to continue, Kira?
Yeah.
Go for it.
And then it would be times 1 minus 1.45.
1 minus
Wait.
1.45.
45. Yeah, 1.45.
1.45, like that.
To the t power.
All that to the t power. You're really, really close. I'll let you see if you can find it, and if not, you can hand it off to someone else. It has to do with, yeah, that inside factor. You got the initial amount, correct.
I don't know.
Okay, you can call on someone.
Wyatt.
I think that the 1 minus is good, but the 1.45 is incorrect because that's like you're adding 1.45 and we're not increasing here, so I think it'd just be 0.45.
Okay, so this should be changed to 0.45. Is that what you're going to say too, Jid? Yep. And then the reason for that, again, is if this was the depreciation is 145%, then you would be correct. It's 1.45, but 45% is, we'll do our notes out here, 45% is really 45.0%. So there's our decimal place, and I move it twice to the left, so that turns into 0.45%, or 0.45 not percent. Yeah, Esha.
And you'd add it plus 1, but since you're not.
Oh, yeah, then we'll do 1 minus whatever that decimal is in this case. Just like our formula says up here. 1 minus whatever that percentage is as a decimal. Asha?
So wait. So does this have any? Do we not add the 1? Why don't we add the 1?
So adding the 1, whenever we add, then that means that the factor is going to be bigger than 1. Bigger than 1. So 1 plus something is bigger than 1. Therefore, our factor will be bigger than 1.
So we don't. Okay, because we want decay. Okay.
Yeah, we want exactly the factor less than 1 in order to get decay. So we're going to subtract by that percent.
Okay, so that's basically just, okay, I get it now.
Okay, and just in case other people have a similar question, the reason that we always use the number 1 is if I multiply by 1, nothing is happening. I'm still getting the same number. So multiplying by 1 minus a little bit is just having a little bit of decay. And there's our answer. Done. Let's try example number 2.
But that's all we need to do.
That's all you have to do. Yeah, it's going to go fast. Example number 2. Who wants to do it? Yeah, question, Emma. Or is it a hand, Emma?
It's yeah, that one my card.
Oh, yes, go for it.
Aluminum-296 is a radioactive element that will eventually be discovered by a future female scientist. This element loses 7/9 of its mass every day. A sample of aluminum-296 has 350 grams. Write a function that gives the sample's mass in grams. T days from today.
There it is. So I made up an element. Can you guys figure out who it's named after? Yeah.
That's how I wanted to read it.
Nice. Okay.
Young Miss Ross.
So once you discover that, that's going to be awesome. I base it off of the current periodic table of elements because there's nothing that has a atomic mass of 295. So once we find the atomic mass of 295, then if it's 296, that's going to mean it's radioactive. You'll learn a little bit more about that in biology. I might be totally wrong by how I'm using that logic, but that made sense to me. Yeah, Wyatt?
Can I try
Can you wait until after?
starting with my-
Oh, yeah, go for it.
So, like you said, 296 is the atomic mass, but I think 350 grams is still the starting amount because like 296 is just saying where it is on the periodic table.
Yeah, it's exactly. Cool, thank you. Did you want to continue, or do you want to just leave it there and leave someone else to?
I'll let someone else continue.
Perfect, thank you. We'll give it to Jade if there's no one else. But I know, sorry, Jade, I'm going to definitely give it to someone else because we don't have everyone in yet. I need to hear from either Larissa, Ugo. Did I get Ulysses? Did I get your card, your imaginary card yet? No? Okay, one of you three I need to hear from. I'll give you guys a hint. I'm going to multiply by something. I need to figure out what that something is. And you're just using the formula up above. Yeah, Ugo.
Do the 1 minus.
Yep, 1 minus, and then what? 7/9, yeah. Thank you. And that's going to be all to the power of t, yeah. So typing this in won't be correct in Khan Academy. We need to now simplify that inside, but yeah, that's the basic setup. We just subtract whatever it's talking about right here. Lose 7/9 means subtract 7/9. And just as a hint to you guys, you eventually are going to be doing both exponential growth and decay. So knowing these keywords like lose or gain is important, so you can be like, is this going bigger or smaller? Oh, smaller because it's losing, so subtracting. So just as a heads up. Ulysses?
So if it was like instead of gain, it'd be add.
Exactly, yes. All right, so last thing that we need, I'm going to give it to Larissa. I need to add, or I have to subtract 1 minus 7/9. And I'll give you a hint. We need like denominators, so this is really 1 over 1 minus 7/9. What do I need to do to 1 over 1 in order to subtract, Larissa? Multiply by 9 over 9. Cool. So now I have 9 over 9 minus 7/9. And go ahead and tell us our final answer for our factor, Larissa. You're really, really close. What's 9 minus 7 is actually a positive number, though.
Oh, 2.
Yeah, so it should just be 2 9. Yeah.
Why did you do 9 over 9 minus 7?
That's a great question. Next time, raise your hand, though. And then can someone answer that really good question? Why did I multiply by 9 over 9? Kira?
9 minus is equivalent to 1 over 1, and so you have to make them have common denominators because when you add and subtract fractions, they have to have the same. So you just multiply it by the
That was a great explanation. Thank you.
How can we still finish dividing them?
Like turn it into a decimal, you mean?
Yeah.
You totally could, yeah. So does anyone know how to divide by 9s? The decimal approximation? Okay, I'll teach you something new today. I'll show you a pattern. Let's see if you can figure it out. 1 divided by 9 is 0.1 repeating. 2 divided by 9 is equal to 0.2 repeating. 3 divided by 9 is 1/3, which is 0.3 repeating. So if you saw the, well, I already gave you 2/9, but if I gave you 7/9, it would be what?
0.7.
Oh, yeah, I should have asked for quite right hands, but you guys can probably figure out it's 0.7 repeating. It's kind of a fun little trick with dividing by 9s, and it works with that 1/3 rule. So 2/3 is 6/9, and that's 6 repeating. Cool, so it works out, right? So yes, you could totally do that. By the way, I've memorized this word, and I didn't think I would, but this bar here is not called a bar, it's called a verniculum. It's super fancy-pantsy to memorize that word, and I'm never going to quiz you on it, but Mr. Brown might, because he's the one that was quizzing my pre-calculus class. So now you know it's called the verniculum. Yeah, so we can have our final answer down here that capital E, Emanium, E of t, is 350 times this 2/9, all that to the power of t. And that's how you'll enter it into Khan Academy.
Will Khan Academy already have the E and T or whatever?
Yes, they'll do the same thing where they'll give you this part, and you just have to enter in.
It actually does work. It actually does work in the way that it does work in like the it doesn't work as it also works as the solution as I figured out.
Oh, okay, nice. Ashley, question?
So we'll just okay. So we get rid of the 1 because we added the 1 into that already, or we subtract the 1 into that.
Yeah, we simplified what is 1 minus 7/9, and we did that work up here, 1 minus 7/9, and we boil it all the way down into 2/9. Yeah, question, Larissa.
How can we do that to the top one?
The top one, we didn't do that. Oops. Yeah, can you log the teacher error? I should have done it to the top one.
I was wondering that. I was like, maybe that's just.
You have to have the confidence to ask. I make mistakes all the time. I'm still learning too. Yeah, we should have made this. Can someone give me what this should have been, Wyatt?
0.55.
0.55 to the power of t. Yeah, thank you for catching that, Larissa. Thank you for answering that, Wyatt.
So why is it still because you added?
What? Yeah, it's just I don't know, what grade do we learn decimal subtraction? 5th grade or something? What is 1 minus 0.45? And you can do it on your calculator, or you can say 1.00 minus 0.45. All right, well, we have to borrow the 1. That turns into a 0. That turns into a 10. I have to borrow again from that 10. That 10 turns into a 9. That turns into a 10. 10 minus 5 is 5. 9 minus 4 is 5. 0 minus 0 is 0. Bring the decimal down, 0.55. Yes.
I have the lesson or the papers for 8-4 and 8-5.
Yes.